Hi, our lesson now is about the future value and financial applications. Let's start talking about compound interest. In a compounded interest, if you deposit a certain amount in bank and you want to know what's the value after 10 years, if you are depositing this amount and you are taking a compounding interest on this amount, then this is the right formula that we will be using. The formula is the future value FV is equal to the present value times 1 plus R over K times 100 to the power of Kn. Now, FV simply means the future value. PV is the present value. R is the interest rate. And K is the compounding periods per year. And the last thing is N is simply the number of years. Now, for the value of K, if the deposit is compounded, if it is compounded yearly, then the value of K is equal to 1. If it is compounded quarterly, then the value of K quarterly, because I have quarterly compounding for each 3 months. I compound once. So how many compounding periods per year would be? I have 4 compounding periods. And if it was compounded monthly, which means I compound each month, having the compounding periods per year to be equal to 12. So if I compound yearly, it means I compound once. Quarterly, I compound each 3 months, so per year I compound 4 times, so the value of K is 4. If it's monthly, then the value of K will be 12 because I compound 12 months. If I compound semi-annual, it means I compound each 6 months, then the compounding periods per year would be equal to 2. By this, I can find the value of K. Let's solve a question from the IB question bank now. In this question, give all answers correct to decimal places. Diego deposits 8,000 Argentine pesos, ARS, in a bank account which pays a nominal annual interest rate R equal to 15%, compounded monthly. Compounded monthly, it means that K is equal to 12. Part A. Find how much interest Diego has earned after 2 years. Okay, now we need to find the future value. We have, for part A, the future value is simply equal to the present value, which is 8,000, times 1 plus the rate, interest rate, which is 15, over k times 100. K is 12 times 100, all of it to the power of k times n. So k is 12 times n, which is the number of years. This is equal to 2. So now the value of the future value is, we have to go to run matrix. It's 8,000 times 1 plus the rate, which is 15, over k, which is 12 times 100, all of it to the power of k times n, which is 12 times 2. And now the future value is 10,778.81. So it's 10,778.81. This is the future value. The question asks about the interest. Simply, the future value is equal to the present value plus the interest gained. So I have 10,778.81 is equal to 8,000 plus I. So the interest gained is equal to this value minus 8,000. So this amount minus 8,000, I will have the interest gain to be 2,778.81. So it's 2,778.81. This is for part A of the question. We found the interest gained. So now, let's go to part B. Carmen also deposited in a bank account. Her account pays a nominal annual interest rate 17%, compounded yearly. When I say compounded yearly, it means that the value of k is equal to 1. After 3 years, the total amount in Carmen's account is 10,000. Find the amount that Carmen deposited in the bank account. Okay. Now I need also to use the same formula, which is the future value. So I have the future value in here to be 10,000, because after 3 years this is the value, so the future value is 10,000, is equal to the present value, I don't know the present value, times 1 plus 17 over k, which is 1 times 100, to the power of k times n. K is also 1 times n, which is 3. Now I have one unknown. I can simply use the solver on my graphical display calculator to find the present value. So I go to menu, and then I go to equation, and then I go to F3, the solver, just delete it. I have 10,000 to be equal to the present value, as make it as x, times 1 plus fraction 17 over 100 to the power of 3. And then I execute again. I find that the present value is equal to 6,243.71. So the present value is equal to 6,243.71. 243.71. And by this, I could find the present value by simply using the solver on my graphical display calculator.